Discuss about the expressions of Kc, equilibrium constant in terms of concentration. We move into equilibrium expressions in terms of concentration. So it is the example is the first one. I have taken nitrogen with hydrogen and it is changing into the products ammonia. We'll see how we can write. There is a very vital part in Kc concern. There wouldn't be any reactants or products in the solid state are not included in this Kc expression. We call concentration of a solid is a constant. So as the concentration of a solid is a constant, it is not included. It is any kind of either solids or the liquids or the solid reactants or products in this equilibrium expression. Example number one, the Haber process of producing ammonia. So the case in terms of concentration, ammonia gaseous concentration to the power 2 as there are 2 in front of the balance equation, and the nitrogen gaseous to the power 1 multiplied by hydrogen gaseous to the power 3. So once you substitute with the concentration units, it becomes this expression would be, so this ammonia gas to the power 2 divided by nitrogen gas to the power 1 multiplied by hydrogen gas to the power 3. So there are two concentration terms, mole square decimeter minus 6 up, and it would be 4 concentration times mole per decimeter 12, and these two get cancelled, and it is the final, it should become mole minus 2 and the decimeter plus 6 would be the very final units. We can move into example number 2 where it involved a solid reactant. We get example thermal decomposition of calcium carbonate. We can talk about this thermal decomposition. Once the substitute the values, you can see very clearly calcium oxide solid, carbon calcium carbonate also solid, we leave out. So our final cases comes with carbon dioxide gas concentration which is to the power 1. That is the Kc expression for this heterogeneous reaction. This is a question based on Kc. This I got from one of the past paper questions. It says it is the 0.005 moles of hydrogen. This is the initial mole. Is mixed with 0.01 mole of iodine at the beginning. No hydrogen iodide in the medium. So your question is to find the value of Kc including its units. That's the question. Find the value of Kc including its units. We'll see how we can solve this question. Apart from that, the given information at the equilibrium 0.00968 moles of hydrogen iodide are present, and the volume of this container is 1 decimeter cube, where all these reactants and products are present at this equilibrium is reached. So these are the keywords, that the initial number of moles of reactants and products, equilibrium substance, as well as it is the total volume of the container. So those keywords should be bold or underlined before doing any question of this nature. We'll see how we can solve this. It should be clearly identified the given information. These are the initial quantities. Hydrogen iodide was in present, and from 0.005 certain X amount react, 0.01 certain X amount reacts, and at the equilibrium twice the X is produced. So this is the clue to begin today's solving this issue. Twice the X is equals to 0.00968. So this equals to 0.00968, which gives you, so we can get the value of X for this amount being remaining at this. Hydrogen iodide is twice, so the amount reacted X we can calculate. As you see, we can find the X value is half of that. So what is remaining at equilibrium once you subtract 0.005 from 0.005, once it is been subtracted, we can get the answer which is equals to 0.005 minus 0.00486 is 0.00016 remain at the equilibrium of hydrogen. At the same time, this amount would be remaining with this ideal would be, it is that 0.00516 would be the amount remaining with the hydrogen. So at the equilibrium, this quantity percent, this quantity plus 0.000968 is present with the hydrogen iodide. So these are the moles. You will divide that by 1 decimeter cube volume. All these moles should be divided by 1 decimeter cube, so can be obtained the value for concentration. When we divide mole by 1 decimeter cube, so these are the number of moles found for hydrogen and the iodine and the hydrogen iodide at equilibrium. Once we divide each of these number of moles by volume of 1 decimeter cube, it is the concentration of all these three. We'll see how we can get the answer for Kc with its units. This is our Kc expression for this reaction, and these are our moles. We're going to divide that by 1 decimeter cube to get the concentration. So we can substitute those values in terms of concentration, terms of the Kc expression, and simplify, and then we can obtain the final answer. Here it is, substitute the values. You can see these two concentration terms cancel, and for this particular reaction it has no units for the concentration in terms of K equilibrium. So it is the Kc value you can obtain 113.5 with no units, because all the units are cancelled off in this expression. I hope you understood how it is to get the data clearly to substitute into the Kc expression and how to solve questions including the units for Kc. I hope you understood. Thank you so much for watching the video. Hope to meet up you soon with another video with Kp calculations. Thank you for watching the video.